are 4 special lines and triangles that we're going to use this semester. The first one being a perpendicular bisector. So on the top flap, go ahead and write a few things about it. So a perpendicular bisector, number 1, is a line that cuts the base. Oh, let's change that color actually.
Why are you still here?
There we go. Cuts the base into 2 congruent parts. When it's doing that, it also creates 90-degree angles. And the 2 parts, don't forget, are congruent. So 2 congruent parts. I'm actually going to underline that. Oh, and sorry, last but not least, creates 2 congruent sides also, and I'll explain that here in a second. So we have 2 pictures underneath. We're going to practice with them. The first one will give this little guy right here 7x plus 24. And then let's do the other guy, 13x minus 48. And since we know it's a perpendicular bisector because it says it underneath, we can set these equal to each other. So 7x plus 24 equals 13x minus 48. And now we're just doing algebra to solve, right? We can subtract the 7x from both sides and get 24 equals 6x minus 48. We would then add the 48 to both sides, and we would get 72 equals 6x. And when you divide 6 on both sides, you get x will equal 12. And that's how we would use a perpendicular bisector to solve for variables using algebra. Now that third part I said was creates 2 congruent sides. So the bottoms are congruent, and so are these 2 sides here. So 7x minus 22 and 4x plus 5. If we're given both of those sides, we can also set these equal to each other and with algebra solve for x. So 7x minus 22 would be equal to 4x plus 5. I would subtract the 4x from both sides. I'd get 3x minus 22 is equal to 5. Then I would add the 22 to both sides. 3x would equal 27. And when I divide both sides by 3, x would be equal to 9. Okay, that's perpendicular bisector. We have another bisector. Right next to it is the angle bisector. The angle bisector cuts the angle into 2 congruent halves. And also we can create right triangles out of this. Okay, so again, 2 congruent halves. So when we see the word bisector, we know we can start setting things equal to each other. So if I said this half was 5x minus 11, and this bottom half was 8x minus 41, I can set those 2 equal to each other to solve for x. So 5x minus 11 equals 8x minus 41. I can subtract 5x from both sides, so negative 11 equals 3x minus 41. I would then add 41 to both sides, so 3x would equal to 30. And last but not least, divide 3 on both sides, x would give us 10. That second part I said can make right triangles, and the legs of those right triangles that are created would be congruent as well. So for example, it's 4x plus 30 and 9x minus 5. What I can do is set those 2 equal to each other. So 4x plus 30 equals 9x minus 5. Again, start by subtracting 4x from both sides, so 30 equals 5x minus 5. Then you can add 5 to both sides, so 5x on this side, 35 on the left. Divide by 5, divide by 5. X would be equal to 7. And at any point, please pay attention. Obviously, we were given no clear directions, but sometimes after finding x, you do need to plug back in and find actual length measurements. So please just make sure we're paying attention to what the questions are asking for. The third line is a median. Median is a segment. It joins a vertex to the midpoint of the opposite side. So remember, if we have a midpoint, that means we have two congruent sides. So midpoint and congruent sides, just in case. So this picture, right, if this is a midpoint, like they're telling us at the bottom, this side is 22, that means this side has to be 22. If this is 8x minus 27, and this is 4x plus 33, I can set them equal to each other. And again, use algebra to solve for x. I always subtract my smallest variable over, so subtract the 4 over, which means I would add the 27. 4x equals 16. When I divide both sides by 4, x would be 15. And again, if they ask me for the measurement of any of those sides, I would plug x back in. Last but not least is our altitudes. There we go. Okay, an altitude is a segment again. And that segment joins, well, these are not elbows and knees, joins a vertex to the opposite side. And in this case, it doesn't meet at the midpoint, but it meets perpendicularly. And that means perpendicular means we're going to be getting a 90-degree angle. And that means I have right triangles. In middle school, I know you guys learned the Pythagorean theorem. The a squared plus b squared equals c squared. And c is the hypotenuse. Hypotenuse, I think that's how you spell it. So for example, if I were to cover this up, right, I could call this little guy the A, this guy the B, that side the C. And now while I'm looking at the other side, I have a B right on the left, right? This is the B again, which means this would be my A and this would be my C. Now let's practice this with a little bit of algebra. If I said this was x, this was y, this side was 16, and let's do 22 and 30. There we go. We're going to solve for both x and y. To solve for x, we only look at that left triangle. And it doesn't matter what order I put my legs in, I just have to make sure I put my hypotenuse by itself. In this case, it is x. And everything has to get squared, so please be using your calculator when doing this, because it does not mean we are timesing by 2, it means we're timesing it by itself. Then you can just add those two numbers on the left. You should be getting 740. And last step is to take the square root of both sides. So x squared equals, in this case, 27.2. You do get a decimal, so I'll just go ahead and round it. And let's also solve for y. So 16 squared plus 30 squared equals y squared. Again, and this time our variables happen to both be our hypotenuses, but remember your hypotenuse is always across from the 90-degree angle, so just pay attention to where your 90-degree angle is in your picture. And again, we're going to be squaring, so 16 squared is 256, 30 squared is 900, I get this y squared. When you add them together, you should get 1,156 equals y squared. And again, use your calculator, do square root, and you should get 34. If you cannot remember how to do a square root on your calculator, that is okay. I'm going to put the reminder here at the bottom of the notes. And you're only going to need this for altitude, so you can put it underneath. Oops. You can put it underneath your altitude word. Sorry about that. So you would always hit the second button first. Then you would hit the x squared button. And then you would type in whatever number. So then type number. And then hit the equal button. And that should get you a square root. To get a square, you would just not push the second button and follow the rest of the steps. So this is for square root. For squaring anything, again, just start at that step right there. Let me know if you guys need help. You're going to move on to your practice assignment now.